January 4th, 1945. Kobe Airfield, Formosa. Lieutenant Commander Hiroshi Takeda watched through binoculars as American aircraft emerged from the overcast sky. What should have been a routine enemy air raid became something far more significant. An American fighter damaged, trailing smoke descended rapidly toward the runway. Minutes later, Japanese ground crews surrounded an aircraft that would fundamentally challenge everything their military leadership had been telling them about American fighter technology. The Grumman F6F-5 Hellcat that crash-landed on that airfield that morning became the most dangerous weapon Japan would face in 1945. Not because of what it could do in combat, though it was deadly enough, but because of what its existence meant. For the first time, experienced Japanese pilots would get their hands on an intact American carrier fighter. They would tear it apart. They would study it. They would fly it. And then they would tell their superiors a truth that no one in the Japanese military wanted to hear. America had not just matched Japanese air power. They had made it obsolete. This is the story of what happened when the rising sun met 2,000 horsepower of American engineering and lost. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The morning of January 4th, 1945 dawned clear and cold over the Japanese-held island of Formosa, known today as Taiwan. At Kobe Airfield, mechanics and pilots moved methodically through their morning routines. There was nothing unusual about the day ahead. Routine patrols had been scheduled. Anti-aircraft gunners manned their positions. The base itself was well fortified, built into the hills with dispersed hangars and ammunition storage carefully concealed beneath camouflage netting. At 7:15 a.m., the air raid sirens wailed across the field. American aircraft were inbound. This had become an almost daily occurrence by early 1945. But this particular strike was different. Among the attacking Hellcats, one aircraft began to fail. Engine temperatures spiking into the red zone, fuel pouring steadily into the cockpit from a damaged fuel selector valve. The pilot, Commander Charles V, August of Fighter Squadron 44 aboard the USS Langley, faced an impossible choice. He could attempt to nurse the crippled fighter back toward friendly waters, hoping to make it to an area where rescue might be possible, or he could put it down immediately, here, in enemy territory. Both options meant captivity or death. August chose survival. With smoke pouring from his engine, August pushed the nose down toward Kobe Airfield. The runway, though enemy-held, was concrete and relatively clear. It was going to be close. The engine was failing, temperature gauges spinning wildly toward critical zones. The propeller had already begun to lose RPM, that distinctive sound changing to something like a cough. August switched to a belly landing gear up, flaps down, pray. The Hellcat touched down hard, skidding across the concrete in a shower of sparks and smoke. It was a violent landing, the kind that would have normally torn the aircraft apart. But the Grumman designers had built these fighters to absorb punishment. The airframe held. The fuselage remained intact. When August finally came to rest in clouds of dust and burnt rubber, he was alive. Within minutes, Japanese soldiers surrounded the aircraft. August, dazed from the violent landing and coughing from smoke inhalation, was pulled from the cockpit at gunpoint. He was exhausted, bleeding from a gash across his forehead, and acutely aware that he had just become a prisoner of war. What the Japanese soldiers didn't yet understand was that they had captured something far more valuable than a single American pilot. They had captured a window into American industrial capability, a window that would reveal truths that contradicted everything their military strategists had told them about the air war. The Hellcat that August had crashed was a Grumman F6F-5, Bureau number 71441. It carried the latest Pratt Whitney R280010W Wasp engine, a masterpiece of American engineering producing 2,000 horsepower with water injection capability. Every system in the aircraft represented the state of American fighter development. The aircraft was equipped with 6 .50 caliber machine guns, capable of delivering devastating firepower. The cockpit was surrounded by 200 pounds of armor plating. The wings possessed aerodynamic sophistication that Japanese engineers could only study and wonder at. The Japanese command quickly recognized the significance of their prize. Within days, senior staff from the Naval Technical Office arrived at Kobe Airfield. The aircraft was examined meticulously, photographs were taken, dimensions were measured, drawings were made. Engineers crawled over every inch of the fuselage, running their hands across the smooth aluminum skin, studying the riveted construction, analyzing the engine installation. What they found was both impressive and deeply troubling. Lieutenant Commander Takeda, one of Japan's most accomplished test pilots, was summoned to examine the aircraft in detail. Takeda had been flying military aircraft since 1937. He had logged thousands of hours in Japanese fighters. He had studied captured American aircraft before. But as he walked around this Hellcat, crawling into the cockpit, studying the instruments and systems, something felt different. This aircraft seemed to have been built with unlimited resources. Every component was precisely manufactured. There were no shortcuts, no substitutions, no signs of wartime austerity measures. By contrast, the last Zero that Takeda had flown had been built with recycled aluminum. Certain alloys that should have been specified in the plans had been replaced with inferior substitutes. The oil was lower quality than optimal. The spark plugs were unreliable. Every system reflected the reality of a nation struggling with resource shortages. The Hellcat in front of him reflected a different reality entirely. After preliminary examination, it was decided that the aircraft should be transported to Japan for more comprehensive evaluation. In late January 1945, after careful disassembly and secure packing, the Hellcat was loaded aboard a cargo vessel bound for the Japanese mainland. The journey took over a month, the ship crossing waters increasingly dominated by American submarines and surface vessels. But the precious cargo arrived safely at Yokosuka Naval Air Base on the coast of Honshu. Yokosuka was Japan's premier naval air facility, the center of Japanese naval aviation development and testing. The base was home to some of Japan's most experienced test pilots and aeronautical engineers. It was also one of the most heavily damaged bases in Japan, having been subjected to repeated bombing raids that had destroyed much of its infrastructure. Buildings stood as burned-out shells. Runways had been cratered and repaired multiple times. Fuel shortages meant operations were severely constrained. Yet despite the damage, Yokosuka still possessed the capability to evaluate and test aircraft. The Hellcat was moved into a relatively undamaged hangar, and work began immediately. Over the course of February and March 1945, Japanese engineers conducted what might be considered the most thorough forensic examination of any captured Allied aircraft during the entire Pacific War. They disassembled the Hellcat systematically. Every engine component was removed and studied. The Pratt Whitney R-2800 was torn down completely. Cylinder heads were examined. Connecting rods were measured. Valve timing was studied. The fuel injection system was analyzed. The supercharger was dismantled and its compression characteristics documented. What the engineers found was revelation upon revelation. The engine itself was a marvel. The R-2800 was air-cooled, which meant it didn't require the complex water cooling systems that added weight to inline engines. Yet, it produced 2,000 horsepower at combat power. By comparison, the Nakajima Sakai engine in Japan's most modern Zero variant produced only 1,130 horsepower. The power differential was not marginal, it was fundamental. Every ounce of additional power translated into speed, climb rate, acceleration, and the ability to dictate combat terms. But the power output was only part of the story. What truly astounded the Japanese engineers was the quality of the engine's construction and the precision of its manufacturing. The cylinder liners were perfectly finished. The connecting rods appeared almost laboratory-grade in their precision. The valve seats were machined to microscopic tolerances. Every component reflected the capability of a manufacturing system operating with abundant resources and sophisticated machine tools. By this stage of the war, Japan's manufacturing capability had deteriorated catastrophically. American bombing raids had destroyed countless factories. Remaining production facilities had been dispersed into caves and tunnels, where equipment was often jury-rigged and precision work was nearly impossible. The workforce was increasingly depleted, as experienced machinists had been drafted into the military. Young workers and women had replaced them, often without adequate training. The quality of aircraft components reflected this deterioration. Japan's latest fighters were being built with parts that didn't fit properly, materials that weren't to specification, and assembly work that was increasingly shoddy. By 1945, readiness rates for Japanese aircraft had plummeted because so many aircraft simply didn't have all the required parts or had parts that were defective or worn out. As the Japanese engineers examined the Hellcat's Pratt Whitney engine more closely, they began to understand the magnitude of the gulf between American and Japanese industrial capacity. This wasn't just a bigger engine. It was a demonstration that American factories could produce complex, high-precision components at massive scale. The engine weighed only slightly more than the Zero's engine, yet it produced nearly twice the horsepower. It was lighter, more efficient, and more powerful, a triple achievement that spoke volumes about American design sophistication. The airframe was equally revealing. The Hellcat's aluminum skin was smooth and uniform. The rivets were perfectly countersunk, creating a surface as smooth as mirror glass. This aerodynamic refinement had measurable effects on speed and fuel consumption. The wing design was advanced, with proper laminar flow considerations built into the geometry. The fuselage shape was carefully optimized. The cockpit enclosure was a transparent bubble that provided 360-degree visibility luxury compared to the framed canopies of Japanese fighters, which offered worse visibility and added unnecessary weight. The structural design was robust in a way that reflected American design philosophy. The entire airframe was built around a principle of damage tolerance. If a shell punched through the fuselage, the aircraft would continue flying. If a wing spar was damaged, the structure had built-in redundancy. The undercarriage was sturdy and reliable, designed to withstand the rough treatment of carrier landings and emergency belly landings like the one Commander August had performed. By contrast, Japanese fighter design philosophy emphasized lightweight and maneuverability over structure robustness. A Zero weighed thousands of pounds less than a Hellcat, which was why it could turn inside any American fighter. But that light construction meant minimal armor protection and less structural redundancy. A Zero damaged in combat was likely a dead Zero. A Hellcat damaged in combat might fly home. The armament was another. Revelation. 6. 50 caliber machine guns, each capable of firing 500 to 750 rounds per minute, meant the Hellcat carried tremendous firepower. Japanese fighters typically mounted a combination of cannons and smaller caliber machine guns. The cannons were effective against bombers, but hard to aim accurately in fighter-to-fighter combat. The smaller caliber weapons had limited stopping power. The Hellcat's arrangement was designed specifically for aerial combat against fighters, and the 300 rounds of ammunition each gun carried meant sustained firepower that could shred an opponent in seconds. The ammunition storage system was efficient and well protected. The gun bays had access panels for reloading that made ground crew work easy. The weapons were synchronized to fire through the propeller arc without hitting the blades, a technical achievement that Japanese engineers knew was difficult to accomplish reliably. By early March 1945, after weeks of intensive examination, the Japanese had catalogued and photographed every significant component of the Hellcat. They had documented engine specifications, performance characteristics, aerodynamic features, and structural innovations. The information was compiled into reports and disseminated to Japanese aircraft manufacturers and the Imperial Navy's Air Technical Office. The message in those reports was unmistakable. Japan could not match this aircraft. Not with the current state of manufacturing capability, not with the available resources and materials, not with the existing design philosophy and engineering practices. The Hellcat represented a level of industrial sophistication and engineering excellence that Japan's aviation industry simply could not achieve in the remaining months of the war. Some test pilots and engineers argued that if Japan could somehow capture a production line or import the plans and begin manufacturing Hellcats under license, perhaps something could be accomplished. But everyone understood that this was fantasy. The American production machine was beyond reach. By March 1945, American factories were producing aircraft faster than Japan could build them by a factor of 3 or 4. American aircraft were superior in performance. American pilots were better trained. American logistics were superior. The examination of the captured Hellcat had confirmed what the most realistic military planners in Japan feared but could not openly acknowledge. Japan was losing the air war, and there was no realistic possibility of reversing that situation before the war ended. The most difficult task fell to Lieutenant Commander Takeda. He was called to Yokosuka's command headquarters and given a direct order: evaluate the Hellcat in actual flight. Every technical understanding in the world meant nothing compared to first-hand flight experience. Takeda needed to strap into that aircraft, start that engine, and feel what flying a Hellcat felt like. Takeda prepared for the flight with mixed emotions. Part of him was curious, genuinely eager to experience this American fighter firsthand. Part of him was apprehensive. The aircraft had suffered damage in Commander August's forced landing. It had been transported across dangerous waters. It had been torn apart and reassembled by Japanese technicians, working with incomplete documentation and limited familiarity with American systems. Everything about the flight was risky. The aircraft might not fly properly. The engine might fail. The fuel system might malfunction. But orders were orders. On a clear morning in late March 1945, Takeda climbed into the Hellcat's cockpit. The seat seemed to envelope him in a way that Japanese cockpits didn't. The controls felt heavier, more substantial. The instrument panel was dense with gauges and switches. He studied the layout carefully, cross-referencing with the technical documentation that Japanese engineers had provided. Ground crews had positioned the aircraft on Yokosuka's northernmost runway, pointing away from the base toward open water. If anything went wrong during takeoff, Takeda would have a chance to eject into the sea where rescue submarines might be stationed. Takeda performed the startup sequence carefully. The Pratt Whitney engine coughed to life. It was louder than a Japanese engine, with a deeper, more powerful sound. As he brought the throttle up slowly, the engine settled into a smooth, even rhythm. Every indication showed normal. Oil pressure was good. Cylinder head temperatures were rising properly. Fuel pressure was stable. Takeda advanced the throttle further. The aircraft began to roll. He released the brakes fully, and the Hellcat accelerated, and accelerated, and kept accelerating. The power of the machine was astonishing. Japanese fighters needed long takeoff runs because they were relatively light and had limited engine power. But the Hellcat was heavy and powerful. The acceleration was relentless. The aircraft left the ground in what seemed like half the distance Takeda expected. Once airborne, Takeda banked the Hellcat gently and began climbing. The rate of climb was impressive. At 1,000 feet per minute, the Hellcat was ascending faster than almost any Japanese fighter. At 2,000 feet, Takeda began to get a sense of the aircraft's handling characteristics. The control forces were firm but not excessive. The aircraft responded immediately to control inputs. It felt solid and capable. There was none of the delicate, almost fragile quality that Japanese fighters had. The Hellcat felt like a truck compared to the sports car nature of a Zero. Takeda accelerated in level flight. The airspeed indicator crept past 200 miles per hour, then 250, then 300. The aircraft was moving with remarkable smoothness. There was no buffeting or unusual vibration. The engine remained smooth and powerful throughout the acceleration. By 350 miles per hour, Takeda realized he was approaching the Hellcat's cruise speed. This was faster than most Japanese fighters could fly, period. And it was cruise speed. The aircraft could go faster if pressed. Takeda pushed the throttle forward, adding water injection to boost power even further. The airspeed indicator began climbing past 370 miles per hour. The aircraft continued to feel stable. There was nothing twitchy or unstable about it, just inexorable acceleration and climbing performance. The thought crystallized in Takeda's mind as clearly as if someone had spoken it aloud. Japanese fighters cannot catch this aircraft. It was a stunning realization. Takeda had fought against American aircraft before. He knew the capabilities of F-4U Corsairs and earlier Hellcat variants, but this F6F-5, with the 2,000 horsepower engine and the refined design, this was something else entirely. The speed advantage alone was decisive. In aerial combat, speed was equivalent to altitude. It gave the Hellcat pilot options that Japanese pilots simply didn't have. The Hellcat could choose to fight or disengage at will. It could dictate every aspect of combat. The flight lasted less than 30 minutes, but it had accomplished more than weeks of technical analysis. Takeda had experienced American engineering excellence firsthand. He understood now, in his bones, what the numbers meant. When Takeda landed and climbed out of the cockpit, he was met by a group of officers, engineers, and technical staff waiting to hear his evaluation. Every eye was on him, waiting for his assessment. Takeda looked at them for a long moment. He thought about how to describe what he had experienced. He thought about his duty to provide an honest evaluation. He thought about the implications of what he had just learned. Finally, he spoke. His words were simple and direct, but they carried the weight of someone who had just confronted a hard truth. "We cannot win the air war," Takeda said. "This aircraft is superior in every measurable way except maneuverability at low speed, and their tactics prevent us from exploiting that single advantage. They have the speed to control engagement. They have the power to climb away if they choose. They have the armor protection to survive hits that would kill us. Unless something changes dramatically, the skies over Japan belong to America." The officers and engineers standing around him said nothing. There was nothing to say. They all understood what Takeda was communicating beneath the surface of his words. Japan had lost the air war. The Hellcat on the runway in front of them was proof, and from this moment forward, the question wasn't whether Japan could win. The question was only how long it would take for American air superiority to become absolute. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late April 1945, the technical reports and evaluation data from Yokosuka Naval Air Base had circulated through the highest levels of the Imperial Japanese Navy. The information was classified as highly sensitive and distributed only to senior officers and aircraft manufacturers. What the reports contained was a detailed assessment of everything Takeda had experienced and documented during his test flight and the subsequent technical examination of the Hellcat. The message was relentless in its clarity. The F6F-5, equipped with the 2,000 horsepower Pratt Whitney engine, represented a complete generational leap in fighter technology. The specific power output 2,000 horsepower versus the 1,130 horsepower of the most modern Zero variant translated into concrete, measurable advantages that Japanese fighters could not overcome. But more troubling than the performance metrics was the underlying reality that these numbers represented. The Hellcat wasn't just a better aircraft. It was evidence of American industrial capability that had moved beyond anything Japan could match. In the offices of the Aeronautical Department at the Naval Technical Bureau, engineers pored over the specifications. One senior designer, an engineer named Yamamoto, who had worked on the Zero's original development, made notes in the margins of the technical report. His handwriting became increasingly agitated as he worked through the implications. The Hellcat's construction tolerances were tighter than anything achievable in Japanese factories by 1945. The casting processes used for the engine block were producing results that Japanese foundries simply could not replicate. The aluminum alloys used in the airframe were of a purity and consistency that suggested unlimited access to primary materials, something Japan had lost when American submarines began systematically destroying Japanese ore transport vessels. in 1944. The water injection system, which boosted the Hellcat's engine power during combat, represented engineering sophistication that Japanese industry could theoretically understand but could not practically implement at scale. The carburetor design was revolutionary. The fuel management systems were elegant. Every component reflected the fact that the aircraft had been designed without the constant compromises that Japanese designers had to accept due to material shortages and manufacturing limitations. Yamamoto's conclusion, which he wrote at the bottom of his analysis, was blunt. This aircraft cannot be matched with existing resources or production capability. Japan cannot build this aircraft in quantity before the war ends. Even if we could obtain the plans and specifications, our manufacturing system lacks the precision and the materials to produce components of this quality. The reports were forwarded up the chain of command, reaching Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet. Toyoda read the technical assessment with the steady awareness of a man watching his nation's position in a war become increasingly untenable. He had already received reports of heavy losses in recent operations. He knew that American forces were consolidating control over vast stretches of the Pacific. He understood that the strategic situation was deteriorating week by week, but this report about the Hellcat added a dimension that went beyond military setbacks. It was confirmation of something that Toyoda's most realistic strategists had long feared. Japan had fallen behind in the technology that would define modern warfare. Toyoda authorized distribution of the technical findings to the Mitsubishi and Kawasaki design bureaus. Both companies had programs underway to develop fighters that might match or exceed American designs. Mitsubishi was working on the A7M Super Ryzen, intended to be a successor to the Zero. Kawasaki was developing the Ki 61 Hien, a liquid-cooled fighter that represented a departure from the traditional air-cooled engine philosophy. But when the Hellcat reports arrived at these design offices, the reaction was one of grim resignation. The engineers at Mitsubishi understood immediately that the Super Ryzen, even in its most optimistic specifications, would not match the Hellcat's performance. The aircraft existed only on paper. Prototype construction had been delayed repeatedly due to bombing damage to facilities and material shortages. The design itself was sound, but it would not fly before the war ended. The situation at Kawasaki was equally bleak. The Ki 61 was more advanced and showed promise, but production had been sporadic due to constant relocation of manufacturing facilities to avoid air raids. Only a handful of aircraft were flying operationally. Dozens more sat in various states of assembly, awaiting components that were increasingly difficult to obtain. What the engineers at both companies realized, after studying the Hellcat reports, was that Japan's entire approach to fighter design had been rendered obsolete. The fundamental design philosophy that had made the Zero dominant in the early war years, lightweight, maneuverability, range, was no longer sufficient against an enemy that had combined power, armor protection, firepower, and still maintained acceptable performance. The Hellcat was a masterclass in balanced design. It gave up some maneuverability to gain speed. It accepted additional weight to gain structural robustness. It sacrificed some range to achieve power output, but in doing so, it had created a fighter that was dominant in the combat environment that actually mattered: high altitude, high-speed engagements, where the enemy pilot could dictate terms. One designer at Kawasaki, a man named Fukuda, who had helped develop the Ki 61, sat in his office and stared at photographs of the Hellcat. The aircraft looked fundamentally different from what he was accustomed to designing. The engine cowling was streamlined in a way that suggested the designers had gone to extraordinary lengths to reduce aerodynamic drag. The fuselage shape was optimized for speed. The wing design showed evidence of careful aerodynamic analysis. Fukuda thought about the design process that had gone into the Ki 61. His team had done excellent work. The aircraft was competitive, but it had been developed with the constant awareness that materials were limited, that manufacturing facilities were vulnerable to bombing, that every design decision had to account for the possibility of substituting materials or simplifying production processes. The Hellcat represented the opposite philosophy. It had been designed with unlimited resources in mind. Every component was optimized for performance. Manufacturing was conducted in vast, secure factories. Quality control was rigorous. If a component didn't meet specifications, it was scrapped and rebuilt. There was no question of substituting inferior materials or accepting lower tolerances. The psychological impact on Japanese aircraft designers was profound. For the first time, many of them confronted the reality that their nation's aircraft industry was not competitive with American capability. They had known intellectually that American production was higher. They had read reports of American aircraft losses and understood that the United States could replace those aircraft faster than Japan could produce replacements. But seeing the Hellcat actually having the specifications and design data in front of them made the situation visceral. Japan was not just losing the war. Japan was being out-engineered. The reports from Yokosuka triggered a cascade of decisions in Tokyo. The Naval General Staff reviewed the situation and came to a conclusion that was both obvious and devastating. Conventional fighter operations would become increasingly untenable as American aircraft, like the Hellcat, became more prevalent over Japanese territory. The immediate response was to accelerate the kamikaze program. If conventional air combat had become unwinnable, then the logic went, Japan should rely on attack methods that did not require air superiority. Kamikaze attacks, piloted by pilots with minimal training, could still inflict damage on American ships. One Hellcat could be intercepted and shot down. One Zero piloted by a minimally trained kamikaze pilot could still potentially reach an American vessel and inflict damage. It was a strategy born of desperation, and the evidence that conventional air power could no longer defend Japanese territory. News of Takeda's assessment spread through the pilot corps, though in fragmented and often distorted form. In pilots' ready rooms across Japan, the conversation evolved. The propaganda that had been distributed for years, claims about the superiority of Japanese fighting spirit, assertions that no American aircraft could match Japanese aircraft began to crack under the weight of contradictory evidence. Veteran pilots who had been fighting since 1941 understood what Takeda's evaluation meant. They had fought against Hellcats and knew exactly how outmatched they were. A pilot named Yoshida, who had flown Zeros since 1942, expressed the sentiment bluntly in a letter to a fellow pilot. The Hellcat is what happens when you have unlimited time and unlimited resources to design an aircraft. We designed the Zero under the constant pressure of time and material constraints. We did the best we could, but best effort is no match for American industrial capability. For newer pilots, the revelation was more shocking. Many had been trained on propaganda that emphasized the superiority of Japanese equipment and the way that fighting spirit could overcome material disadvantage. Learning that their aircraft was fundamentally inferior in performance was psychologically destabilizing. A young pilot named Endo, who had graduated from flight school in early 1945 with less than 50 hours of flight time, wrote in his personal diary after hearing about the Hellcat assessment, "They tell us we must fight with determination and courage. But courage does not make an aircraft climb faster. Courage does not add horsepower to an engine. We are being asked to fight in aircraft that cannot catch the enemy. This is not a matter of will. This is a matter of physics." The psychological toll on the pilot corps was immense. For years, pilots had been told that their aircraft were superior to anything the Americans could produce. They had been told that the Zero was the finest fighter aircraft in the world. They had been told that Japanese pilots were better trained and more dedicated than American pilots. All of it had proven false, at least compared to the Hellcat. Some pilots responded by requesting assignment to kamikaze units. If they were going to die, and many understood now that this was likely then, at least kamikaze attacks offered the possibility of inflicting some damage on the enemy before death came. Other pilots responded with resignation, flying their remaining missions with the fatalistic acceptance that they were essentially flying to their deaths. The most senior and experienced pilots had a different response. They began, quietly and carefully, to discuss the reality of Japan's situation. In private conversations, often in locations away from official oversight, experienced pilots began to acknowledge what the Hellcat's existence had made undeniable. Japan had lost the air war. One famous pilot, a man named Hanada, who had flown Zeros since 1937, was captured by American forces in late 1945. When interrogated, he was asked about the performance of the Hellcat compared to the Zero. His response was candid. The Hellcat is superior in every way that matters for modern air combat. The Zero is faster in certain low-speed maneuvers and can maintain a turn better than the Hellcat. But the Hellcat is faster, stronger, and can fight on its own terms. The pilot of a Hellcat controls the engagement. The pilot of a Zero must fight according to what the Hellcat allows. This is why the Hellcat dominates. The examination of the captured Hellcat at Yokosuka revealed something that extended beyond aircraft performance. It revealed the comprehensive superiority of American industrial civilization. Every detail, the precision of the manufacturing, the quality of materials, the sophistication of systems integration, the robustness of the design, all of it spoke to a different level of industrial capability. Japanese designers understood that even if the war continued and Japan somehow developed aircraft that matched the Hellcat's performance, this would mean nothing if Japan could not produce them in similar quantities. American factories were producing aircraft at a rate that Japan simply could not match. Statistical reports arriving at the Naval General Staff painted the reality starkly. In 1944, American aircraft production had totaled over 96,000 aircraft of all types. Japanese production in the same year had been approximately 28,000 aircraft of all types. The ratio was more than 3-to-1. By 1945, with American production continuing at high levels and Japanese production collapsing under the weight of bombing, the gap had grown even wider. The Hellcat represented the culmination of this disparity. It was not just a better aircraft, it was an aircraft that could only be produced by a nation with America's industrial capacity. For pilots who understood this reality, the implications were clear and devastating. They were not fighting individual battles against individual opponents. They were fighting against an industrial machine that could produce thousands of Hellcats and replace pilots at will. They were in a war where American pilots could eject from damaged aircraft, be rescued by submarines or rescue vessels, and return to fly another day. Japanese pilots, if shot down over water, would likely die, and there was no rescue infrastructure to retrieve them. By May 1945, the psychological collapse of the Japanese pilot corps was becoming evident in combat reports and squadron records. Pilots were reporting higher stress, more psychosomatic illnesses, and greater reluctance to fly. The official response from high command was to intensify indoctrination in the traditional values of Bushido and to emphasize the honor associated with sacrifice. But the propaganda was increasingly hollow. The pilots understood the reality. They had seen the evidence. They knew that they were flying aircraft that could not win. By June 1945, the situation had deteriorated to the point where even the most optimistic planners in Tokyo could no longer ignore the reality. The Hellcat had proven itself in combat again and again. American pilots were flying with near-total impunity over Japanese territory. The B-29 bomber campaign, initially slowed by long-range problems and navigation difficulties, had evolved into a systematic destruction of Japanese cities. The captured Hellcat had served its purpose it had provided, a definitive proof of what many had suspected. Japan had not fallen behind in the air war. Japan had been completely defeated in the air war. What remained was only the final chapter, the conclusion of a story that had already been written by physics and industrial capacity. The examination of that single F6F-5 at Yokosuka did more to demoralize Japanese military leadership than any number of battlefield defeats. A battle lost could be explained as tactical error or temporary misfortune, but an aircraft that represented the complete technological superiority of the enemy that could not be explained away or overcome through determination. The Hellcat was not a weapon that could be defeated through courage or tactical innovation. It was a physical manifestation of the reality that Japan's war effort was futile. Every pilot who flew against Hellcats learned this lesson firsthand. Every engineer who studied the captured aircraft's specifications learned it intellectually. Lieutenant Commander Takeda, who had flown the captured Hellcat and delivered his damning assessment, would survive the war. He would eventually become part of the post-war Japanese aerospace industry, but he would carry with him for the rest of his life the memory of that flight, the memory of sitting in the cockpit of an aircraft that represented American power in its most tangible and undeniable form. The 2,000 horsepower of the Pratt Whitney R2800 engine had not just represented power in an abstract sense. It had represented the power of an industrial civilization that had committed itself to the Pacific War and had the capability to sustain that commitment indefinitely. When Japanese military planners finally decided to end the war in August 1945, after the atomic bombings and the Soviet invasion of Manchuria, one factor that had weighed on their deliberations was the unmistakable reality of American air superiority. The Hellcat had played a role in that decision not as a direct military weapon, but as evidence that Japan could not win. The examination of the captured Hellcat served as a final, definitive proof of what the statistics had been suggesting all along. Japan had lost the industrial competition that underpinned modern warfare. Japan could not produce aircraft as good as the Hellcat in sufficient quantities to defend against them. In the cockpit of a Zero, flying against Hellcats, Japanese pilots faced not an enemy aircraft, but rather a symbol of American civilization's overwhelming material advantages. Every pilot who encountered a Hellcat understood this at a visceral level. The aircraft did not just defeat them in combat, it demonstrated that the war was unwinnable. The final tally of the war in the Pacific would reflect this reality. By the time Japan surrendered, American aircraft had achieved total air superiority. The Hellcat and its sister aircraft had destroyed thousands of enemy planes. Japanese airfields had been systematically destroyed. Japanese cities had been reduced to ash and rubble by B-29 bombers, flying without fear of fighter opposition. The captured Hellcat at Yokosuka never flew again after Takeda's test flight. It was eventually damaged during subsequent Japanese operations and abandoned when the war ended. American forces that occupied Yokosuka after Japan's surrender found the Hellcat's remains, photographed them, and recorded what had transpired. The post-war examination of captured aircraft revealed details that Japanese engineers had already understood too well. American test pilots who flew the recovered aircraft at Yokosuka in the weeks following Japan's surrender were struck by the aircraft's condition. Despite months of operation under Japanese control, despite the stress of a test flight conducted by an unfamiliar pilot, despite the rough handling that many captured aircraft endured, the Hellcat's structure remained sound. The airframe had been built to absorb punishment. Japanese engineers who collaborated with American specialists during the occupation noted the meticulous construction standards evident in every system. The riveting patterns on the fuselage, the welding quality, the precision of the fuel system installation, all of it reflected manufacturing practices that had been impossible in Japan by 1945. The Americans did not just build better aircraft, they built them with a consistency and quality that suggested unlimited time and resources for perfectionism. This stark reality would influence Japanese industrial and aerospace development in the post-war period. The engineers who had studied the Hellcat, who had recognized its superiority, who had understood the gap between Japanese and American capability, would carry that knowledge into the reconstruction of Japan's economy. The lesson was simple and unforgiving. Quality, precision, and systematic improvement were the foundations of competitive advantage. For Lieutenant Commander Takeda, who had flown the captured aircraft and lived to see the war's end, the memory remained crystal clear. In post-war interviews, decades after the war, Takeda would still speak of that flight with the clarity of a man describing a moment when the future suddenly became visible. He had felt, in the responsive controls and powerful acceleration of that Hellcat, the full weight of American industrial civilization. He had understood, in those moments at altitude, that his nation faced an opponent that could not be overcome by will or determination alone. The Hellcat's test flight at Yokosuka had been brief, lasting less than an hour. But in that short time, it had accomplished more than countless policy discussions or statistical reports. It had provided proof that transcended numbers. It had made the invisible visible. It had transformed Japan's military leadership's abstract understanding of American superiority into a concrete, undeniable reality. In the end, a single aircraft that had force-landed on a Formosan airfield due to engine failure had accomplished what countless battles could not. It had provided the Japanese military with undeniable proof that they were fighting an enemy with superior capability that could not be overcome through will or determination alone. The 2,000 horsepower of the Hellcat's engine was unstoppable, not because it was the most powerful engine in the world, it was not. The Hellcat was unstoppable because behind that engine, and behind every other Hellcat in service, stood an industrial civilization that had decided to fight the war to completion and had the resources to do so. Japanese pilots, in their final evaluations and testimonies after the war, would consistently return to this theme. The Hellcat had been superior, it had been dominant, most importantly, it had been representative of something larger, the fundamental military and industrial superiority of the United States. One captured Zero pilot, interrogated after the war, was asked if he thought a skilled Japanese pilot could defeat an American pilot flying a Hellcat, given equal circumstances. His answer was measured and realistic. Perhaps, if the Zero pilot had superior training and experience, and the Hellcat pilot was inexperienced. But the Hellcat is designed to prevent such equal circumstances from occurring. The Hellcat can choose when to fight, where to fight, and when to disengage. The Zero pilot cannot. This was the final realization, not that the Hellcat was a better aircraft, but that the Hellcat embodied a completely different approach to warfare. It was designed to operate in an environment of abundance, abundant fuel, abundant replacement parts, abundant pilot training, abundant aircraft. A Japanese pilot flying a Zero operated in an environment of scarcity. Fuel was rationed. Pilots received minimal training, replacement aircraft were difficult to obtain, and if the pilot was killed, there was no reliable way to produce a replacement quickly. The captured Hellcat had made this disparity visible and undeniable. It had transformed an abstract knowledge of American industrial superiority into a concrete understanding of what that superiority meant for the outcome of the war. In the cockpit of that aircraft, Lieutenant Commander Takeda had learned a lesson that would define not just the end of World War II, but the entire post-war international order. Material capacity, industrial sophistication, and systematic excellence ultimately determine the outcome of great power competition. The war was over. The Hellcat had proven unstoppable, and in that proof lay the seeds of Japan's post-war commitment to industrial excellence and quality, a commitment that would transform the nation's economy in the decades that followed. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.